Hey ladies and gentlemen, welcome to the second part of the OOP concepts here in Java programming. So for now we know what variables are and we know what functions are. So what I want us to learn now is objects and classes. Now in order to learn what an object is, we need to know what a class is first, because a class is a blueprint from which you can create an object. So we use classes to create objects. Classes don't consume any memory inside Java, but objects do, because they are derived from classes when instantiated. So let me explain what all this means. So here I have my small app here, which only does one thing, is to print hello world, using that as we have seen before. Now let's say, for example, I am tired of printing this every time I want to print something. I want something simpler. Let's say if only I had to do this, print like that, and then say hello world like this. How would I go about doing that? Well, I can create a function to do this for me. So here I can come and say static, because we are in static mode, and so for me to call a procedure directly from within here, it has to be static, a procedure that lives in here. So static void, because it returns nothing, we're going to call it PR like that, and then we're going to tell it that we expect a string from there, and then we're going to give it a name message, that string. So this is just a variable. Of course you can name it anything you want. And now if I grab this and bring it in there instead, like so, then things will work out. So instead of printing a very hard-coded message, I'll just say whatever message is supplied, print that instead. So just like that, now all I need to do to print a message is just say PR and say type my message in there, and it will be printed. So you can see here, if I repeat another message, so I can print two messages like this using the same procedure, calling it several times. So let's give it a shot and see how that works. And then if I now run the app like so, of course I get hello world and another message. Great, nothing fancy here. But now this thing I have here is a class. Now if you observe the class here, it has two functions in there, or methods. Now within a class you can have variables as well. Now keep in mind, like I mentioned earlier, the variable you declare in here is not accessible to the variable in there, and vice versa, but you can put a variable at the top here that will be accessible to both of these. Now in order to experiment, let's create a new class of our own. I'm just going to type the word class, and I'm going to call this one student, or let's just call it car, for example, just for the sake of giving examples. Now just by doing that, I've created a class. Now what exactly is a class? A class is a blueprint. So let me explain a little bit more using Paint here. So now imagine you have an actual factory and you want to be printing cars, for example. Okay, you want to be manufacturing cars. Now before you make your car, you need a blueprint for the car, a design for that car. So that thing is going to be on paper. It won't be a real car, it will just be on paper and not a real object. It's just a representation of the object. So you have a blueprint here that shows the design of your very expensive car over here, right? Very good. So your car is on paper. This is a document, by the way. Now from the document, you need to push this document into a factory. So the factory here will manufacture your car. So there's all these moving parts in here that will end up creating, I'm trying to make gears here to show that there's a process going on here that creates an actual car. So once at the end here, you're going to have an actual object, which is the actual car that you can touch and move around with over here. Now the beauty of this process is that this is the same blueprint, right? But you can print 10 cars from the same blueprint. So for example, you can be printing cups. For example, you have one blueprint but print 100 cups from there, that same blueprint. Okay, so we have 2 cars from the same blueprint here. These are called instances right here. So this is an instance. Hopefully I can type the word instance properly here with my mouse. Okay, there we go. So this one here is an instance of the car here. So car class is there. And these are instances of car over here. And then there's a process in between that creates the car. Now think of this blueprint here as the class. So this one is the class. Okay? This is an instance over here. These at the end here, the results, are the instances of this class. Now in this process, if let's say one of these cars is damaged, maybe this one is damaged for some reason, while it's driving it's damaged, that does not affect the original class here, because this is just a version or an instance of the original class. So hopefully that is understood. If the car, one of the cars here in cars damage, or it's completely erased, you can delete one of these cars and burn it or something. That does not affect the original blueprint here. So in the same way, if I create a class here in Java, and then I create an instance, because we're going to be creating instances of those classes, if I do something to the instance, or I change something in the instance, it doesn't change, it doesn't affect the actual class. So you should keep that in mind. But if I affect the class itself, if I change something about the blueprint, anything I print after that is going to be affected. So keep that in mind. So let's say I have this blueprint here and I print 2 cars. Then I make a change to the blueprint. I say, oh no, I think we need a window over here. That would be much better. Then anything I print after that will have that window now. And this is how things work as well in coding. So if, for example, I have a class here and then I change something within the class afterwards, any instance I make after that will have that new change. So the question is, how do you, let's see here, let's do some real world examples for coding in here. Now before I go to there, let me explain about properties and methods. So a class has 2 things. It's got properties and methods. Okay, properties, I can type props. I'm just going to call them props here. And then methods, right? Obviously. Methods. There we go. Okay, so the difference between the two is that a property is something that the actual final object, the instance here, something that it has, and then a method is something that it does. So one thing is what it has, one thing is what it does. So the differences could be in terms of a car, because a car has color, right? These are props. So a prop could be something like color. Okay, so color is a property because it's just a value. So it's just a value of one of the things about the car. So it's a value. A method is something that it actually does. For example, it can drive or it can move. Let's just use the word move in this case. Okay. So any activity is method. Any value is a property. So hopefully that's understood. So like color, a car has a window, that's a property. It's got wheels, that's a property. But when the wheels turn, that's a method because they are doing something. It's an activity. Moving is an activity. Turning is an activity for a car. So those are methods. And then everything it has is a property. So where we create this process of creating from class to object. So hopefully this instance is also called an object here. So keep that in mind as well. So this thing here is an object. It is an object, but it's of type car, right? It's an object of type car. So it's an object that is an instance of car. So hopefully that's understood. So let me give probably a real world example here. So in this case, let's say we have this car class. We can have something like string color is equal to blue, like so. Okay, and then we can have a method. Now the method is void because it just does an action in this case. So void move, for example. And then for our sake here, we're just going to print a message and say the car is moving. So we run some kind of process and then the car is moving or something. Okay, so that's a variable here. It just holds a value, and this one is an activity. So in order to instantiate this class or create an object from the class, all we have to do, let me remove these here for now. We're just going to ignore this function here. So what I'm going to do here is say, in order to instantiate a class, because we can do certain things with a class without instantiating it, and I'll explain how that is done, but we need to make an instance and create an object. So I'm going to say car. So you have to tell it first of all the type of object is going to be, because remember we are creating an instance of car. So I'm going to say car. So I'm just going to call it car, like that. So this is just a variable. So I can call it A, for example, and just say car A is equal to, and then I use the new keyword, new car. Let me capitalize that, like so. Okay. So here, if you notice the classes are capitalized, this is just a convention. It's not required. You can use small letters, but it just makes it easier to understand that this is a class. And methods have small letters, so keep that in mind as well. It's just good practice. So here when I say car is equal to new car, is the same as this manufacturing process here. So I'm getting a blueprint and creating an instance. So that's what I'm doing. So A now contains everything that car contains here because it's a copy of it, right? So now, for example, I can do a system printout here and just say, let me grab this for printing. So here I can print and just say, I want to print a.color. So A, and then you put the dot to access any of the two things here, either the property or the method. I'll still use the same dot there. So this dot just says, I want to get something from within this car class, and I want to check the color, for example. So here when I say a.color, it's going to return whatever value is contained there. So let's get back here and just try to compile this and see if it works. So we're going to go javac app.java, and it has worked. And then let's try to run it now and see. We should get blue if everything runs well. And there we go, we get blue. Very simple and straightforward. And then I can say also print a.move. But because this is a method, this is a function, I have to put open and close brackets like that. And that's because there are certain times I need to pass a value in here. So I'm going to put it in those brackets. But even with an empty value, we still put the braces to tell the program that we're trying to run a function. Because there could be a property called move as well, and a function called move. So for it to differentiate between the two, one should have brackets, the other one wouldn't if it's a property. So when you're trying to retrieve a property, no brackets, it's just a variable. When you're trying to run a function, you put those brackets just like you would when you're just running it directly. So in here, let's try again. I'm gonna do javac app.java. Okay, so void type not allowed here. Right. Wait a minute, what's going on? Void type not allowed. Oh, I see. Okay, so the reason it's complaining that void type not allowed here is that, you see, I'm trying to print the result of this activity here, but remember that it's not returning any result here. So the result of running this operation is void. So what it means is that if I put it here, I'm returning the value void. It's as good as saying system.out.println and then void here, because the result of what I was doing is a void. So I can't put void here and emptiness. I need a string here. Printing can only print a string. So instead, let's just run it as if we're just running the function, like so. Just say a.move, because it's already doing the printing within it, right? It's not returning anything. So in this case, let me try that again. And it works. So let's clear the screen and let's try to run it. Java app. So you see two things. Blue, the car is moving. Also, if I was returning something here, for example, let me undo what I did here. This would have been fine if this was returning a string, because you see, this returns a string. When I try to print, a.color is blue, which is a string. And printing requires a string of some kind. Okay, it could be a number, but it requires a value in here to print. But this a.move returns nothing. It doesn't return any value. It's just a void. So we can change that by just saying string move, and then we say return there, and then we return a string instead, like so. So when we say string move, we return a string that says the car is moving. So now if I run this, because it does return a string, it's as good as putting this string in here, and when we run that, it's as good as putting that string in there. So this will work fine now. So I'm going to say javac app.java, and then I'll run the Java app this time, like so, and then blue, the car is moving. Great. Okay, so hopefully this is understood, but let's do a more practical example in here. Let's try the a class called student, for example. Now I can have, within student, I can have marks, for example. Let's say a student would want, let's say, results, right? Let's say a student has results. In this case, the int math, I'm going to use result like this. Math result is equal to, now these will be percentages, right? I'm going to say maybe in math this guy got 90, this student. And then I can repeat this math and go English, and then go maybe math, English, and science. So maybe here this one got 50% and this one got 80%. Okay, and then we can have a method within the student class that does, let's say here it's an int. Let's say calculate total, okay, results. Calculate total result. So what will it do? It will want to calculate the result here. Now, in order to reference the result here, now think of this in a little bit more detail. When we said car A, because we made this A an instance, then we could access things like math result from using A. I can say A dot math result, right? Now, what if I'm within the class? I can't reference A here because I don't know what the name of the instance will be, whatever instance I make. Because let's say I want to get math here, because I want to add all these guys. I'll just need to say return. The result is going to be math result plus English result plus science result. Okay, like this. This is what I return when I calculate the total. But if, for example, within here I had declared another integer called math result is equal to 9, for example, then it's going to grab this one. But what if I want to grab this one that's there, because this one is like the main thing? So I would use the keyword this. Now what this does is it references whatever instance was created by the user at that time, whatever this, because remember these are copies. Let me come back here for a second. Remember that we have this class here, okay? And then we have these copies here. So at any given moment, if I say I make a copy of this car and I want to get its color, it will be this car.color, right? The color of this particular car. But what if I want to write that from the standpoint of the class? I'm just going to use this. And this will refer to the current car that you are dealing with at that time. So if I'm dealing with this car, the this is talking about this particular car. But if I'm dealing with this one, this is referencing this car. So that's what we use this when we don't know which instance will be that instance at that time. So we just say this dot. So in other words, what I'm just trying to say is when you're referencing things from within the class, you use this. If I had another function here that I wanted to run, I would say this dot that function, and it will know what I'm talking about. So even if I had this like this, math is equal to 9, because these two are the same, it will know that I'm talking about this one and not this one. So let's just do that in here. Now, even without this, it would work like this. It would still know that because there's only one version of it, so it will just grab there. But it's good practice to do this just to be very specific. So in this case, things have changed. We no longer have an object called car. We have student. So I'm saying student A, meaning this A is of type student and not of type int, not of type string, it's of type student. So this is a new item I've created in this application. It's called student. It's not a string, it's not an integer, it's a student. So A is a student now. And now if I say A dot math result, you know what the math result will be. And then I can also say A dot calculate total result, and it will give me the total result. So here I can put in some text as well and concatenate like this. So I'm going to say math and then say total. Now I can also put a tab by doing /t like this to tab in so that things are neat and nice like so. This is a tab key. So I'm adding the result of the math and that one total there. So student is equal to new student, and then we get the result like that. Okay, great. So if I go back here and let's clear the screen, I can do javac app.java, and then once I'm done, I can now run java app. So it shows me that the math of this student is this, the total is that. Now, what about a string name, right? So we're going to say string name is equal to unknown for now, right? So we don't know who this student is. So this is an unknown student, but these are the results. Okay? Or let's put John Doe for now, just so there's a name there. Okay? So that's a string because it is a string. So calculate result. Then I can have another method that tells me the name of this student. but I don't need that for now because I can just grab it directly from there and just say student.name, and that's it, right? So let's try that. Here I will put student.name. I'll just say name here, and then here it's a.name because that's the student name. So let's try this again so that it makes more sense. So I'm going to say javac, javac app.java, and then finally let's run our app. So you see the student's name is John Doe, math result is that, and the total result is that. Now let's say I want to store information for a different student in here. So I could, now keep in mind you can see the original data, right? So if I come here and let's say a.name is equal to Mary Poppins or something, okay? And then just like that, that name has changed, even though I haven't changed the math result, right? Keep that in mind. So let me come down here. Let me do this afterwards. So I'm going to duplicate this. And let me remove that. Okay. And then here, I want to change the math result as well. So I'm going to say a.math result is equal to 30, for example. Okay, so the rest I've left as they are. The English result, same. The science, I've changed the math result. So think about it here, what I've done. I've created a new instance of a student called A, and then I've printed out their details. Then I have changed one of the details, two of the details, and then print out again. So let's see what we get. So this is very straightforward. We will get what we think we will get, like that. Okay, and then now I can say Java app, like so. Now you see we have name John, math 90, total there, and then again name Mary Poppins, math 30, and then the total 160. So you can see now that the total is calculated based on this new math result, and so the total is different. So as you can see, if I change something about the same instance, because remember, this is the same instance. If I damage one of these cars, it remains damaged, of course, no doubt about that. But what if I create a new instance? Think of it this way. I have echoed out this or printed out the name, the result, and so on, and then I have changed the stuff here. But then I create a new instance instead. So come here, new instance, and this instance is called B. So I'll change all these to B, 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 right? So even though I've changed something inside A over here, A is a different instance, even though they all come from the same class. So I've changed something about A, and we'll never see this Mary Poppins. All we're going to see is the new instance called B, and it will have the original values which it got from the class itself. Okay, so the class here, the name, the original name is John Doe. So on both cases, I'm just going to see John Doe. I will not see the result of changing anything because I printed before I changed this A, and then I changed something and then created a completely different instance which does not affect A at all. So if I edit anything in B, it does not change what's inside A, but when I create them, they get all the default values here. They all have this function. They all have these values here. So it's as simple and straightforward as that. So let me try again CLS. In this case, you're going to see that we'll get the same results on both cases. So Java app. So both instances have John Doe, same. Everything is the same, because changing one instance does not affect the other. Even if I had created this instance right at the top here, you see. So I create that and I create that. So we have both of these. And then finally change something inside A. whenever I try to print B, I will not see a change either. This changed A but did not change B, because B is a separate instance to A. So hopefully this is understood. So you may be thinking, what's the use of all these classes anyway? Well, the use will be apparent once you start actually using the code in real-world projects. Because an object is like a data type of some sort. So instead of you, let's say, for example, with this example we've done here, instead of you creating variables to hold all this data that belongs to the same one student, right? You can just grab this object that has slots for you to put all these values in one place like this, and then you have them at your disposal when you need them. If you've got student A and you want to know the results, you just do student A dot result. What are the results for A? And you get them. You don't have to look for the variable that belongs to A, because you know there's one object that contains all the information about that one student. So this is a way of packaging information into one space like this. Now there's more benefits to OOP, as we're going to see, because there are these things like encapsulation, abstraction, and even inheritance. All these are very, very powerful things that you can use in your application. So this is an introduction to an actual class and what it is. So to recap again, a class is a blueprint of an object. An object is just an item that contains variables and functions, that's all. So it's a group of variables and functions, and it's called a class. And then an object is what you make from a class. When you instantiate a class, when you create a new class, you create an object of that same type. So if the class is a student, you've created an object of type student. This is like having an integer, but integer is something that was built in by Java. But imagine creating your own type. Integer is a type in here, and it's a number type, right? But now you're creating your own thing inside Java, and this thing is called a student, and you can make it so that it has its own properties, its own functions, and it can do very special things within itself. String is an object as well. Just like we've created this class here, that's how string is as well deep down, but it was created by the Java creators instead. So like I said in an earlier tutorial, string is just a type char, but they are just grouped characters, and there's an object which was designed to handle that, and it's called string. So in the same way, you can make your own types like student, car, banana, anything you can create an object of in here, and then define what it does using functions, and then give it properties using variables like this. So I hope this wasn't too complex to understand. If you have any questions, of course, you can always ask me in the comment section, and I will get back to you. All right, so we're going to move on to the next topic in the next video.